Welcome back everyone. Session 7, Cross-Browser, Parallelization, and CI/CD. Everything up to now has largely been about writing good individual tests. Today is about running your entire suite at scale, across multiple browsers and devices, in parallel, split across multiple machines, and automatically on every single commit, without anyone needing to remember to run it manually. This is where your test suite stops being something you run occasionally on your own laptop and starts being a real continuous safety net for your whole team. Quick recap of session 6. The request fixture combining API and UI tests, page.root interception, and wait for response and wait for request. Today's agenda: 6 things: cross-browser projects and mobile emulation, parallel execution, workers and sharding, retries, timeouts, and a real strategy for flaky tests, reporters, HTML, JSON, JUnit, and custom ones, CI integration with GitHub Actions, and Dockerized Playwright execution at a basic level. Let's start with cross-browser projects. Playwright's concept of projects lets one single test suite run against multiple browser engines, or even multiple device profiles, without you ever having to duplicate a single test. Here's the config: an array called projects with 3 entries, one named Chromium using desktop Chrome, one named Firefox using desktop Firefox, one named WebKit using desktop Safari. By default, every test file runs once per project, and you can scope a run down to just one of them. npx playwright test dash project equals Firefox runs only against Firefox, for example. Let's go beyond desktop. The devices import that Playwright ships with contains dozens of preset device profiles, viewport size, user agent string, touch support, all matching real phones and tablets. A few examples: iPhone 14 gives you an iOS Safari viewport, touch events, and a mobile user agent. Pixel 7 gives you Android Chrome viewport and touch emulation. And iPad Pro 11 gives you a tablet viewport, which is genuinely useful for responsive layout checks specifically. Let's see a config that combines desktop and mobile together. For projects, Chromium and WebKit for desktop, and then mobile Safari using the iPhone 14 profile, and mobile Chrome using Pixel 7. A practical tip here: tag your tests as mobile only or desktop only where relevant, and combine that with dash grep, so each project actually runs only the tests that are relevant to it, rather than running your entire suite 4 separate times over, which would be a lot of wasted runtime for coverage you don't actually need. Let's talk about how Playwright gets fast. Parallel executions across worker processes. By default, Playwright runs test files in parallel across multiple worker processes, and each worker is its own fully isolated node process with its own set of test files assigned to it. 2 settings worth knowing: dash workers equals 4 caps, your parallelism at 4 workers specifically, and fully parallel true takes it a step further. It runs tests within a single file in parallel too, not just across separate files. Workers parallelize within one machine. Sharding is the next level up. It splits your entire suite across multiple separate machines, each one running its own slice, typically as a separate CI job. Picture 3 CI jobs, each labeled shard 1 of 3, shard 2 of 3, shard 3 of 3, each one running dash shard equals its own number out of 3, and each one handling roughly a third of all your test files. Afterward, you merge the HTML reports from every shard back together using npx playwright merge dash reports, so you end up with one single unified result to actually look at. Let's see how this actually looks in a real C configuration. A strategy block with a matrix shard index set to 1, 2, 3, 4, and shard total set to 4. Then in the steps, run npx playwright test dash dash shard equals matrix dot shard index slash matrix dot shard total. And then upload the blob report as an artifact named uniquely per shard index, so none of them overwrite each other. This is a really standard CI pattern. The matrix strategy automatically spins up one parallel job per shard index for you without you having to write four nearly identical job definitions by hand. Let's talk about handling the inevitable, because no matter how careful you are, some amount of flakiness happens. Retries :2 reruns a failing test up to 2 more times before it actually gets marked as failed for good. Timeout: 30,000, the maximum time in milliseconds a single test is allowed to run. Expect .timeout, the maximum time a single web-first assertion will poll for before giving up. And action timeout, the maximum time a single action, like a click or a fill, will wait before it fails. A really common and genuinely good pattern: retries process dot env dot ci question mark 2 0. Retry only when you're running in CI and fail fast locally while you're actively debugging something. Let's see all of that together in actual config. Retries conditional on CI as we just discussed. Timeout 30,000 milliseconds. Expect with a timeout of 5,000, and under use action timeout of 10,000. One important thing to know about how retries actually get reported: a test that fails and then passes on a retry gets reported as flaky, not as a clean passed. That distinction shows up right there in your HTML report. Specifically so, flakiness doesn't just quietly hide behind a green checkmark that looks completely fine at a glance. Let's talk about what to actually do when retries alone aren't the real fix, because they're a band-aid, not a cure. Diagnose with traces. Retries buy you time, but the actual trace from that retried run tells you why it genuinely failed in the first place. Don't just add retries reflexively. Retries mask real timing bugs. Investigate the actual root cause before you lean on retries as a permanent solution to a problem you haven't actually understood yet. Quarantine, don't delete. Tag a known flaky test with something like @flaky and actually track it as a real visible problem. Remove that tag only once it's genuinely been fixed. And isolate shared state. Cross-test interference is one of the single most common root causes of flakiness. Check specifically for shared fixtures or shared test data before you look anywhere else. Let's talk about how you actually see your results. 3 main reporter formats. HTML, an interactive report with traces, screenshots, and filtering built in. Genuinely great for local and manual review by an actual human. JSON, machine readable output, which you can pipe into dashboards or your own custom tooling. And JUnit, an XML format that most CI platforms, Jenkins, GitLab, Azure, natively understand and can display in their own UI. You can configure more than one of these at the same time. For example, HTML for humans looking at it locally, and JUnit specifically for CI's own test summary UI. Let's see that in actual config. Reporter as an array. First, HTML with open set to never, so it doesn't automatically pop open a browser tab every time. Second, JUnit with an output file of results.xml. Third, conditional on CI, the built-in GitHub reporter if we're in CI, or list otherwise for clean local terminal output. That built-in GitHub reporter is genuinely nice. It annotates failures directly on your pull request diff, right where a reviewer is already looking. And list gives you clean, readable terminal output while you're actively developing locally. Sometimes the built-in reporters genuinely aren't enough and you can write your own. Here's a simple example, a class called Slack Reporter with an onTestEnd method. Inside it, if the result status is failed, it posts a message to Slack saying the test failed. You implement lifecycle hooks like onBegin, onTestBegin, onTestEnd, and onEnd to hook into the run's lifecycle at whatever points you actually need. For example, posting failures straight to Slack, or feeding results into an internal dashboard. Let's talk about automating all of this. Here's the basic flow, 4 steps. Push or open a pull request. The workflow spins up a fresh runner. It installs dependencies and the browser binaries, and then it runs the suite and uploads the report as an artifact. Worth remembering, npm init playwright at latest, back in session 1, actually scaffolded a working .github/workflows/playwright.yml file for you automatically. So you already have a starting point sitting in your project right now, even if you haven't looked at it closely yet. Let's actually walk through a complete workflow file together. Name, Playwright tests, triggered on push and pull _ request. One job called test, running on Ubuntu-latest. The steps: check out the code, set up node version 20, run npmci for a clean install, run npx playwright, install -- with -deps to get the browser binaries, run npx playwright test, and then, using if : always, upload the playwright report folder as an artifact. And that if always part matters, because it means the report gets uploaded even when the tests actually fail, which is exactly when you need it most. Let's talk briefly about Docker. Browser rendering can vary subtly across different operating systems and different installed system libraries. The official Playwright Docker images pin the exact browser versions the library actually expects, removing that variability entirely. Here's a minimal Docker file from mcr.microsoft.com/playwright with a specific version tag. Set the working directory, copy your code in, run npmci, and then run the tests. 2 things worth knowing. The image tag's version has to match your installed @playwright/test package version exactly. And this is especially useful for self-hosted CI runners, or for reproducing a failure locally in a byte-for-byte identical environment to what CI actually saw. Let's cover today's anti-patterns. Unlimited local retries. This hides genuine flakiness during active development. Keep retries at 0 locally, always. One giant CI job. If you don't shard a genuinely slow suite, every single pull request ends up waiting on the full serial runtime, which adds up fast as your suite grows. Ignoring the flaky status, a test that's retried but eventually passed, is a real bug report sitting right there, not a green check mark you can just casually ignore. And skipping browser binary caching, reinstalling all 3 browsers on every single CI run wastes real minutes. Cache that install step properly. Your turn. 5 things. 1. Add a mobile project like iPhone 14 to your config alongside your existing desktop ones. 2. Run your suite with -- workers equals 2 and compare the timing against a single worker run. 3. Set retries to 2 and intentionally write a test that fails once and then passes. Check exactly how that shows up in the report. 4. Configure both an HTML and a unit reporter in the same config file at the same time. 5. Copy the sample GitHub Actions workflow into a real repository and confirm it actually runs successfully on push. Let's recap. 4 things. Projects let one single suite cover multiple browsers and device profiles without any duplication. Workers parallelize within a machine. Sharding spreads your suite across multiple machines, specifically in CI. Retry in CI, not locally. A test that passes on. Retry is genuinely flaky, not clean, and it deserves real investigation. And configure multiple reporters together and wire up GitHub Actions or Docker for consistent, repeatable CI runs. Next time, session 8, our final session, debugging, visual testing, and best practices. We'll go deep on the trace viewer, cover visual regression testing, walk through a code review checklist, and pull together everything from all 8 sessions into one complete framework overview. See you there for the finale. Any questions, please post in comments section.